guys, welcome back to our group assignment video. I'm Yui Hong and this is the topic that my friend and I choose, which is the technique of integration. So when we talk about integration, the integral is calculated to find the function which will describe the area, the displacement, volume that occur due to a collection of small data which cannot be measured singularly. So when we talk about integration, actually we will think about another words, another symptoms, which is differentiation. They are the same, but they are inverse the process of the differentiation. Next here we got some of the methods for integration. So the first one I would like to talk about is integration by substitution and integration by parts, integration using the trigonometry identities, the integration with using some partial fraction and using the fully partial fraction. Here are some integration formula. There are 14 of it if I'm not mistaken. So I will have some example with these formula to explain how these formulas work. Right now we will have our first example, which is the integrate the 14 x power 6 dx. So when we do this equation, we will take out the 14 first. So 14 is up here, and then we only need to integrate the x power 6. So when we integrate the x power 6, we will add on the power of it. The power here, we will add on 1. So when we want to divide, we want to divide the power 8, which is the 6 plus 1. And totally all of that, and then plus c. So what is the c? The c actually is the constant before the differentiation. For example, I got fx, x plus 2. So when we want to differentiate, which is dfx over dx, it will become 1. Why become 1? Actually, the x here is power 1. We move down and then we minus the power. So when we minus the power, it will become only x0. So x0, as we guys know, x power 0 is 1. So which is 1. That's all. But we want to do the integration. We don't know actually exactly what is the constant. So we managed to put an algebra which is a c. So when we do it, this is just addition. So x power 7 over 7 and plus c. When we do that, we will get here it is 2, which is 2x power 7 plus c. This is our final answer.
Hi guys, like my friend Liu have said earlier, there is many ways to do integration. But here, we are gonna only focusing on one way to do integration, which is substitution. Specifically, we call it as U substitution. In this topic, we are gonna achieve two learning outcomes, which is to acknowledge when to use the U substitution in integration, and the second one is to study the sequences process of solving U substitution through example. What is U substitution? U substitution is a technique used to simplify integration by making change of variable, and that variable we change it into U. Have you wondered when and where we are gonna use U substitution? Let's go find out together.
Okay guys, here I'm gonna teach you 5 steps to do integration. If you're following these steps, then you can find the integration is easier to do. Okay, like in this question, we get integrate x cos x squared dx. The first step you must do is find the inner function. In this question, the inner function we can let it to be u. But the question is which function we will choose to be u. Okay, in this function we are going to choose x squared to be u. Why? Because the derivative of x squared, which is 2x, is similar to the x part of the integral. The x part of the integral is this part, x and dx. Okay, we're gonna do the second step, which find du by differentiate u. Okay, class, when we differentiate u, what we're gonna get is 2x, 2x. We differentiate x squared, we're gonna find 2x. Okay, the next step, we are gonna, here we are just want to the x part, right? X and dx. This, we can arrange it to get the x and dx. I'm gonna show you how. Okay, we are gonna move the x to the right, and we got du equal to 2x dx. Okay, we have the x dx. We can move 2 to the left, and we get du over 2 x dx. Now it's similar to the x part, this part, and this part. Okay, you guys get the idea? Okay, we move to the third step, which is substitute back u and u to the original function. When we substitute u and u to the original function, we will get differentiate cos x, we have changed it into u, x and dx, we can replace it du over 2. Okay, now we can simplify this equation into the constant. We can move it to the front, integrate cos u du. Okay, get the idea? Then we can move to the fourth step, which integrate the whole function with the respect of u. Okay, we can integrate the whole function. We can get 1 over 2. Okay, class, when we integrate cos u, we are going to get, yes, right, sin u. But don't forget, we must put the plus c because we don't know the boundaries. Okay? Okay, move on to the final step, which is substitute back the original value into the integral. Okay, what is the original value of u? Yes, the original value of u is x squared plus c. Then you can get the final answer, 1 over 2 sin x squared plus c. Okay guys, can you get the idea? Okay, if you get a question, remember to follow these 5 steps.
Hi! Alright guys, before I'm going to show to you guys how to solve integral using u substitution, I'm going to show to you guys some tips on how to pick u, because most of the students have problem with how to pick u. Okay, here we go. If the question gives you guys rational function, u will be picked from the denominator. For example, this equation, u will be x squared plus 1. Then, if the question gives you guys exponential function, you will be picked from power of exponent. For example, this equation, u will be x squared. Okay, then if the question gives you guys polynomial function, you will be picked from part inside the polynomial expression. For example, this equation, which one is part inside polynomial expression? This one, right? So, u will be 3 plus 2x. Then, if the question gives you guys trigonometric function plus trigonometric function, you will be picked from trigo with the highest power. For example, this equation. Which one trigonometric function with the highest power? This one, right? So, you will be sine 6x. Alright, and the last one, if the question gives you guys mixed trigonometric function, you will be picked from angle of trigonometric function. For example, this equation. Which one is the angle of the trigonometric function? This one, right? So, u will be x power of 5. Okay, here we go. Usually, most of students have problem on how to solve integral equation with trigo function. This is one simple example to make you guys more clear on how to solve integral using u substitution. For example, integration of sine square 6x cos x dx. How to solve this equation? First of all, determine u. From my previous explanation, if the question gives you guys trigonometric function plus trigonometric function, you will be looking at trigonometric function with the highest power. For example, this question, u will be sine 6x. Then differentiate u, and don't forget to differentiate angle of the trigonometric function. And our equation will be du over dx equal to 6 cos 6x. Then rearrange our equation by left dx on single left hand side, and our equation will be dx equal to du 6 cos 6x. Then rewrite our original equation by replace x with u. So our equation will be u square cos 6x du over 6 cos 6x. Then
simplify the equation, it will be u squared over 6. Then bring outside this constant, which is 1 over 6. Our equation will be 1 over 6 integration of u squared. Then integrate u squared, and our equation will be 1 over 6 u cubed over 3 plus c, and don't forget to plus c. Then multiply 1 over 6 with 1 over 3. So our equation will be 1 over 18 u cubed plus c. Then rewrite the equation by replace u with x. So our equation will be sin cubed 6x over 18 plus c.
Okay, now after listening to the explanation of my friends, now let us do some examples. Our first example is the integration of sin 2x dx. So how to do these kinds of questions? So we can use the method that we have just learned, which is u substitution method. So we have known that we can use the angle in the triangle to become our t. So let our t equals to 2x, and we need to integrate it to find for the dt dx. So our dt dx will equals to 2. To rearrange it, our dx will equals to dt over 2. So now let us substitute our t and dt into our equation. So our equation will become like this. Then we can take out the constant, which is 1 over 2. So it will turn like this. So with the hint that I given here, we can solve the questions. So our answer will become 1 over 2 times negative cos t. So remember, we need to replace back our t into our original equation, which is this. So our equation will become 1 over 2 times negative cos 2x. Then we can rearrange it so that it looks more beautiful. Then this is our final answers. Now let us look at our second examples. Our second example is integration of x power 2 plus 1 over x power 3 plus 3x dx. So to do these kinds of questions, we can also use the u substitution method. So we have learned that we can use the denominator to become our u. So it will become like this. Now we need to integrate our u. So our du will become 3x power 2 plus 3 dx. So we need to replace this part become our du. So we need to rearrange it so that we can replace this part. So we will get 1 over 3 du equals to x power 2 plus 1 dx. So to rearrange the formula here, then we can substitute the u and du inside easily. So we will get integration of 1 over u times 1 over 3 du. Then we can take out the constants, and with the hint that I given here, we will know that we will get the long u plus c here. So remember, we need to replace back our u with the x. So this will be our final answers. Now let us proceed to our third example. Our third example is integration of 2x plus 2 times exponent of x squared plus 2x plus 3 dx. So how to solve this kind of question? We can use the same method that we have just learned, which is u substitution method. So we can let this part become our u. So our u will equals to x squared plus 2x plus 3. So to differentiate this, we will get du over dx equals to 2x plus 2. To rearrange it, we will get du equals to 2x plus 2 dx. So let us substitute our u and du into our equations. So we will get the integration of e power u du. So with the hints that I've given here, we will know that we will get eu plus c. So the same thing, do not remember, we need to replace the u back to our original x, which is these equations. So we will get this as our final answers.
Hi! So before I start, I'm going to give you some quiz for you to refresh your memory regarding this topic. So this is the first question. You can take a moment and pause the video for you to think and answer this question. Alright, I am going to assume that you have paused the video and have the answer. If this is your answer, then your guess is correct. If this is not your answer, then you have to do more revision. Then I'm going to proceed with integration using trigonometric substitution. Alright, so now there are three standard trigonometric formula that you have to know before we are going to deep more in this topic. So, this is the first formula, which is integration du over a square plus u square is equal to 1 over a tangent inverse u over a plus c. This is the second formula, which is integration du over square root a square minus u square is equal to sine inverse u over a plus c. And this is the last formula, which is integration du over u square root u square minus a square is equal to 1 over a secant inverse modulus u over a plus c. Since you have seen all these three formulas, how can we differentiate between them? So, as you can see here, in the denominator part, this one is a square plus u square. Meanwhile, this one is square root a square minus u square. And the last one is u square root u square minus a square. As you can see here, this one is addition. This one is minus, but they have the square root. Meanwhile, the last one, we have u, square root, and we switch between u and a position. Alright, moving on. I am going to give you some examples so that you can make sure that you can master this trigonometric substitution. So this is the first example. This is the question, integration dx over 4 plus x squared. When you see this question, which formula do you think that we have to use? Formula 1, Formula 2, or Formula 3? If your answer is Formula 1, then your answer is correct. This is why, when you see this and the formula, they are not in the same shape, but you can make it the same. What I mean is, here you can see 4, but this one is x squared. But if you think 4 is equal to 2 square, right? So now if you put here 2 square plus x squared, then we will have the same shape as this one, as you can see here. So you just substitute your answer using this formula and you will get the correct answer. So since we are done with the example, I'm going to tell you some key takeaways and common mistakes that students always make when they are solving this specific question. So first, you have to choose u carefully. When you choose the wrong u, then you will not get the correct final answer. Second, you have to replace all dx with du. This one is a very common mistake that even I always make. For the third one is simplify the integrand, use back substitute if needed, and failure to use the correct substitution. This one, it is the same like the first one, which is choose u carefully.
For conclusion, like all my friends have said earlier about the basic formula, the u substitution, how to pick the u, the trigonometry substitution, and the example we have gave to you, we hope this video will help you master this topic. Just keep on your mind, make your basics stronger, and do more exercise.
Thanks for watching!